Widgets are produced by a machine in a factory. When the machine is working properly, the mean weight is 30 grams and the standard deviation is 0.04 grams. It is thought that the setting for the mean has been changed by accident, and it is decided to conduct a test at the 5% significance level to see if it has altered. A sample of 15 widgets is taken and found to have a total weight of 450.4 grams. If we're carrying out a hypothesis test, we need null and alternative hypotheses. The null hypothesis is always the situation of no change. In other words, we're going to say the mean is 30 grams. We're not given any indication that we think it's been changed in a particular direction, either up or down. So the alternative hypothesis here is simply that the mean is not equal to 30 grams, and that gives us what's known as a two-tailed test. The weight of our individual widgets is normally distributed with mean 30 and variance 0.04 squared. Therefore, for our sample, the mean is going to be 30 and the variance 0.04 squared divided by 15, as we have 15 in our sample. What we need to do now is identify the critical region. If we consider the standard normal, that's Z, which is a normal with mean 0 and variance 1, then what we need here for a 5% test, which is two-tailed, is 2.5% at this end and 2.5% at this end. And remember, normal distributions are symmetric, and the mean of this one is 0. From inverse normal tables, I find the value here to be 1.96, and because of symmetry, I can say this one is minus 1.96. I need to find the critical region for my distribution. This distribution just here. It's going to be symmetric about its mean of 30. So the critical region is the shaded region here and the shaded region here. We know that Z is equal to x take away mu divided by sigma. Using the values that we have for this one here, we find that x is equal to 0.04 divided by 15 times the Z value 1.96 plus the mean of 30, and that gives us 30.02. I don't really need to calculate it for this one because I know it's symmetric. So if this one is 30 and this is 30.02, it follows that this is 29.98. Now using our data, 450.4 divided by 15 is equal to 30.027. That's in this critical region since it's more than 30.02. So it's in the critical region, and therefore it's significant at this level of testing. So we would reject H0 in favor of the alternative hypothesis. In other words, we'd have to conclude that the mean has changed.